Alrighty. So Danny, you got the one topic so far. Feel free, anybody else, if they have questions or comments or anything like that, you can always roll with the punches. Um, Danny, sounds like Georgi is going to be out for a bit.
Yeah, Georgi has become a father of a girl, so
Oh,
he's out on a paternity leave. So yeah, I think that we discussed this last week, but while he's out, I'll probably need your support to approve PR and look at them and so on.
yeah, that's fair. I think that's reasonable. I think we can probably um, keep an eye on those things. I'll check with the other people who didn't make the call today, but yeah.
Yeah, Dave and I are planning on reviewing them. So like
Okay.
Danny posted a Slack today, so I'll look at those two by the end of the day. But yeah, I don't know how much we'll be able to like check it, but as long as you ping us that, then we'll take a look.
All right, thanks.
Nice. I saw we had Ron for a half a moment there. I don't think he had anything with the board though, with the doc. There's Dave. Maybe he has anything else we want to talk about while we're here. I know we talked a little bit about the managed service proposal last time. Are we in a good spot with that? Do we feel like we're good to move forward with it, or?
Well, I created a couple of stories in our backlog. Don't know whether you have had the chance to look at them. Haven't started working on them because I'm in the middle of a refactoring that we've been considering for quite a long time. I would like to get this out and then release, and then we can carry on with managed services.
Nice. Well, good. Good. Anything else on anybody's mind? Anything we wanted to bring up or talk about?
Today we had a question from a colleague of mine from SAP about multi-cluster support. I can see him here in the code, all muted.
Yeah, I'm in the call. Hi.
Hey,
So if you want to talk about multi-clusters, I guess we can.
Yeah. Yeah. Yeah, so I'm myself Gauri Shankar, and I'm also part of SAP. And yeah, I was looking into multi-cluster deployment for Kurifi. Yeah, so I would like to understand a bit more about how the multi-cluster deployment may look like if we wanted to install a Kurifi in the multi-cluster deployment model. I looked into a bit how this may look like. Example, before I think you had also an item or paper with the Cube Federation, but unfortunately that paper is no more available. And also in the meanwhile, Cube Federation is deprecated, and then the successor is something different. Example, Karmada or Open Cluster Foundation. So there are, as far as I know, there are a couple things available. So from your point of view, these two things will fit for Kurifi in case someone is really looking into multi-cluster deployment for Kurifi. Yeah. So initially I just wanted to understand because I did some exploration. So how we can really fit in with Karmada. This requires some more changes on the Kurifi side. Probably, I'm not really sure in the code wise we really need to do anything, but at least we need to adopt, example, Helm chart and stuff like that to work with the Karmada, for example. But yeah, so before that, in case if you already looked into it, maybe I would like to hear first from your side that okay, it does make sense, or okay for Kurifi, multi-cluster deployment model does not really make sense. It's really work well only for the single tenant, not really work with the multi-cluster model. So maybe any ideas or pointers would be really great for me to, let's say, look into further.
So we have discussed multi-cluster support several times, on several occasions. I think that the general consensus is that supporting multi-cluster is good because Kubernetes clusters have their limits. And also it can be quite beneficial to support multi-tenants on a deployment, because if every tenant has its own cluster, then this is quite a nice security separation between tenants. Our experiment with KubeFed basically had this idea to have a, so to say, master cluster, whether the Kurify API works, and just materialize workloads on secondary clusters, so to say, and we played with KubeFed to see whether this could work. The alternative approach would be to have multiple Kurify instances on every cluster and somehow figure out how they communicate with each other. I'm not sure which deployment scenario is more useful and making more sense. I also don't know. I'm not. I have no experience with Karmado and the other thing that you mentioned, so I can't comment on both deployment options, which one makes more sense with each technology. So I'm sorry, but I don't have much of an input here.
Yeah, and like I think there's other things that could achieve it, like also like KCP or even crossplane. We haven't like explored those a ton either. But I think with any of these solutions, you're gonna run up into the fact that right now Karifi makes some assumptions that the workloads are running on the same cluster as its control plane for things like logs or like just basically it makes some assumptions that the pods are running on the same thing. So like I think some of the abstractions would need to be loosened up to get the right experience there. Like I don't know, I haven't thought about it in a while, but like I think it'd be interesting for, if I don't know, Garasankar, if you have time, like you could do a proof of concept and show it off. But like I think we're gonna bump into issues with that.
Yeah, so I'm also wondering, so how come a crossplane may help? Because it's also a single cluster, but you need to also think about multi-cluster for crossplane, right? So, but not really sure.
Crossplane is not necessarily single cluster. Like you can, there's multi-cluster modes where you could like have the, I've never done this. Someone explained that it was possible to me once. So take what I'm saying with a grain of salt. But you could create have like the Karifi like workload runner or whatever, create cross-plane compositions, which are then you have cross-plane running on the other, your backend clusters that pull from those and deploy it. Which is similar to the KCP approach where Karifi runs on like your like KCP like pseudo API, and then those app workloads and stuff are replicated to the backend clusters. I've never used Karmada, but I imagine there's a similar like concept of copying resources down to the backend clusters. But like at the end of the day, I think the front like Karifi API needs some way to get information back out of those clusters, and also like figure out how RBAC is going to work for developers interacting with that front like cluster, which may have different permissions than the backend ones. And like maybe that's solved by they're all connected to the same UAA or like some shared identity provider or something. But like I think there's a lot to like unpack for this problem here.
Okay. Okay. Yeah. So because I also drafted something. I mean, today I just looked into a bit in with Karmada. Maybe shall I share my screen and just show it to you what I just drafted? just initial idea. So what I thought about it by looking into the Kamada architecture, how we can fit in Kurifi. But of course, I need to try this one. Basically, I need to do a prototype, but just to give you a high level view how this may look like. Shall I share my screen? Or in case if you have any other topics, maybe I can also show it later. It's okay.
We have one more. I don't know, Adam. I mean, you got the next topic. Do you have a preference on? No? Okay. Yeah, go for it. Let's share your screen. We'll walk through it a little bit.
You know, if you see my screen.
Yep, we can see it.
Okay. So yeah, so I just looked into a bit about Karmada, and so this is more or less same also for open cluster management. That's also the similar tool available which we can use it. But yeah, so the Kamada, I see it's a pretty famous because it's a successor of QFed, and all the concept are inherited from the QFed basically. So in general, when we're talking about Kamada, so basically you will have a host cluster. So there you will be installing the Kamada controllers. Yeah, so this will be running in a Kamada system namespace, and afterwards, yeah, so there will be a virtual cluster. So that's where Kamada provides you an API server. So you will interact with this API server to schedule the workloads or the CRDs. It could be anything in general, yeah. Or else you could also do I think it's called multi-cluster service discovery or multi-cluster ingress discovery. Yeah, you could do quite a lot of things. Yeah, so with Karmada. So how this will basically work is that okay, you will have a virtual cluster, gives you an API. So when we wanted to install the Kurifi, so basically when we are going for multi-cluster deployment, so we need to install the Kurifi across all the workload clusters or member clusters. Yeah. So otherwise, we don't really have a controller, so this won't really work. Yeah. So which means we need to somehow copy everything to all the workload clusters, and the resources are isolated in the namespace level. So that's all taken care by let's say Karmada. So say for example, when you are installing Karmada, so you can just say scheduling type duplicated. So this will automatically install the Kurifi controllers, and you can also say for CRDs, if you want to duplicate it, you can just schedule as a duplicated. So it will create all the required namespace, example CF, KPAC, and then Kurifi. It will create everything. It just duplicate across all the workload clusters. Yeah, and so this all taken care by Kurifi. Yeah. So afterwards, let's say if I wanted to just deploy Cloud Foundry application, so in this case, yeah, you will call let's say CF create example org space, and then in that space, actually, you will try to create a Cloud Foundry application. Yeah. So what will happen is that so here again, from the Kurifi side, we need to implement, there is something called propagation policy. So this propagation policy, you will decide against which workload cluster you wanted to deploy the workload. Yeah. So that's something we need to implement it on the Kurifi side. So Kurifi will create this custom resource called the propagation policy, and then decide where to schedule the application. Yeah. So this means every cluster, the namespace of the space will be duplicated. It could be org namespace or space namespace. It will be duplicated. It will be there everywhere. But based on the scheduling policy, the propagation policy, you can say which cluster you wanted to schedule the app. Yeah. So by this way, the CRD, everything is there. Then application just will be deployed on the specific customer namespace. Yeah. So But still, what I don't understand is that how everything talk to each other. So because if you want to deploy a query feed to a to the workload cluster, so we need to make a change in the query fee Helm chart to adopt to the propagation policy, so that this can be deployed in the workload cluster. So afterwards, we can install the applications, yeah, or deploy the applications. Yeah. So afterwards, we need to also get to know how we can get the CF API, then that can interact with all the workload clusters. So those things still yet to be identified, but I think Karmada is really providing some way how we can have multi-cluster propagation, which means somehow we can make it work. Yeah, so this can work for all the workload cluster with a single endpoint. Yeah, so something like, I don't know.
When you're explaining all those things and all the terms from Karmada, that rings some bells from our KubeFed experiments. So I think that what we did in our experiment back then is to make the query fee API run on the host cluster. And then instead of creating stateful sets or deployments, we changed the controller to actually create federated stateful sets and federated deployments with their own, what was it, propagation policy, I think was the term.
Yeah, exactly.
So yeah, this is what we did in our Explorer. I'm going to try to find the branch where we played around. Hopefully we keep it around still somewhere, so that you can have a look at what we've achieved. But
Okay.
yeah, I think that we just managed to change the default stateful set runner to create those federated objects, and that somehow worked. Having said that, we could probably have the same approach with Karmada APIs, whatever APIs it supports. Maybe just disable the default stateful set runner and come up with your own runner that creates those Karmada resources that are needed to run multiple clusters.
That'd
Can
be
I ask
really
a
great.
question?
Yeah. Sure.
Sorry, I find that discussion very interesting. A short question from my side is, what is the purpose of having the multi-cluster? Is it something motivated by the operation of Corefee and scaling out, or is it also to serve the customer to, for example, serve different regions or different different types of clusters in? Because that is something I would also be very interested in, because we have very different environments where we potentially would operate applications.
I'm not really sure at this point I can share more information, because internally in SAP we are also discussing to have a query fee from SAP side to offer to the customers in a multi-tenant fashion, meaning a shared cluster model. So for that, first of all, we would like to understand the concept and consequences of having such a thing, whether it makes sense to have a shared cluster model, or it will work only for the single tenant model. So that's where I'm trying to explore and then trying to come up with a concept. So I think so. Still, we are discussing in SAP very concrete how this will look. I think as soon as I have more information, I can share. Yeah. So at this point, I cannot share so much.
Anyway, the technical implementation would need to offer some kind of mechanism where the actual user of Corefee can determine where his workload should be scheduled.
Yeah. Yes.
Right. I think that for our KubeFed prototype, we implemented some sort of a propagation policy on the host cluster, something along the lines like, if the application is annotated with a certain annotation, for example, tenant, then use that cluster for that tenant.
Okay.
Something like that.
No, exactly. Here also the same, because all the concepts are just taken from the kubefed. Yeah, so in the Karmada also it's exactly the same, so it's not a difference here. So here you can also see, for example, resource propagation. Yeah, so you have a propagation policy, then you can say this is the deployment. It could be anything. It could be service or deployment, or it could be custom resource. It could be anything. Then you can just say the affinity, which cluster you wanted to schedule it or something like that. Yeah, so this is same from Q Federation. Yeah, here also they just use.
Nice. Yeah, this makes sense. Sounds like, Danny, you're trying to figure out if you can find that branch
Yeah.
with the
I thought that I
Explorer.
had lost all the context, but this introduction kind of brought some memories, so hopefully I would be able to find more details.
Oh, that's good.
Okay, great. Daniel, just ping me as soon as you have the details. Yeah. Okay.
All right.
Thanks.
Awesome. Yeah, thanks for sharing too. That was great.
Yeah, thanks for bringing this up, Dory. One of the conversations that we were having last year when we were talking about Korefi to a lot of people is not a lot of our users are going to just be deploying new applications from Korefi. It requires Korefi to be able to deploy existing Docker-based containers. The second thing was we're going to require Korefi to manage services through Korefi and Cloud Foundry. And the third thing we were hoping would work was also multi-clusters, because not a lot of users out there are just working on a single cluster. And a lot of questions that we got were, we have an organization where there's many clusters that we use, and how can Korefi fit into that? And the best answer we could give to them was, if you could have an individual Korefi installation on each cluster and somehow manage that. So which was not a great answer, but I think there's a lot of people out there who use multiple Kubernetes clusters as part of their everyday environment. And so that's the big motivation. I think somebody was, Wyken, I think, was asking, what's the use case? And so I just wanted to give some context about, we've had conversations at past KubeCons with people who have multiple Kubernetes clusters within their individual organization or setup. And is the best way to manage that to have different Koreefis installed on each of them, or have like a single Korefi instance that can then help them manage apps on that are deployed to different clusters and things like that. So I think it's a question of how best to orchestrate your orchestrator or something very meta like that. But that's really the use case. So we've solved the Docker issue well. I think we're making good progress with the services thing, and if we can get some progress on this multi-cluster stuff, it would be really great to shop around and tell people in the larger Kubernetes community about how we've been solving these very relevant problems for the community. So thanks for bringing this up, and thanks for all your efforts with this.
I just want to like add one thing related to what Danny was saying. I think the right and most interesting place to do some of this copying is like at what I call the extension point, or like the leaf, at the leaf resources. So if you just start copying Korefi resources wholesale, like the CF app CR and stuff down to these clusters, you will need Korefi installed on each cluster to interpret and reconcile those. But if you re-implement like or like swap out like the stateful set runner, for example, or like the route controller, then you can just copy like generic resources that any of these clusters can understand. And then like I think that is an interesting thing to try out. It's basically what Danny and Georgi were doing in that exploration. But like I think you have to expand it to the route controller and stuff.
Okay. So, I mean, so in case if you're keeping everything in a single cluster, example for the custom resources, at some point, if you have 100,000 objects or so, I'm also a bit afraid about the performance of the single cluster holding so much of resources because we already
Yeah.
paid quite a lot.
That's true though, regardless though, right? For the Karmata approach, because whatever's running the Karmata API has to be aware of those resources so it can copy them. Like I don't think any of these solve the scaling from the CRD aspect, but it helps with the scaling from the workload running aspect.
Yeah. Mm-hmm. Yeah.
But anyways, it's all very interesting. I just wanted to add that thought
Yeah.
I had.
Yeah. Thanks a lot. Yeah.
Nice. I do have to drop unfortunately here in just a moment. I don't know, Adam, do you want to give us a quick intro? And I mean,
Yeah.
you're all free to carry on after me too. No big deal.
Yeah, so hi everyone, my name's Adam Fowler. Some of you may remember me from my ye olde Pivotal days. Being an ex-pivot's a bit like being an ex-US Marine, there's no such thing. So yeah, I was in Pivotal from 2018, and then left VMware nearly 2 years ago to go and help a friend out with a software company, and since November launched my own software company. Although to be fair, at the moment we're doing mainly consulting in UK public sector, so central government as well as healthcare. But what I'm looking at doing is I'm seeing a trend for many very small clusters in very edge places. So I'm looking to put together solutions for that. In addition to that, there's the people who write code to go run on those things and make their lives easier. And that's why I see Karifi coming in, particularly on the inner loop. A developer on their machine knows they need to write, a Go app or Node.js app or whatever, but don't particularly want to get into the guts of figuring out how to build a very complex app with many components. So I see Karifi as really being helpful there. I showcased it to a team a week or so ago, and they really liked the idea, so I'm implementing that for them now. In the UK, one peculiarity in the security side of things is I don't think you can actually hit UK NCSE security guidance for public sector without using Istio. I just don't think it's possible. I think you can lie in the documentation, but I don't think it'll actually pass muster. So I'm very keen on testing out Istio. I didn't manage to test it the previous weekend, unfortunately, but I have set aside some time this weekend to go and test that. I'm particularly interested in everyone's thoughts on, like, the old Cloud Foundry days of PDubs. The Cloud Foundry layer was on the live system as well as the development system. I was very interested in what people's thoughts were on, should Karifi be on both, or should aspects of it not be on that, and it should just be, the output is a built set of containers and a description of an end-to-end app, and that should be installed on the production clusters. But that's one of the things I'd be interested in hearing thoughts on. One of the products we're launching is basically, I've called it the Bilby inventory because I'm terrible at naming things, as anybody who saw me work on the pandemic stuff will know. And that will basically manage the automated deployment of Ubuntu server and micro K8s and AN app onto any infrastructure that's connected to that particular Bilby router instance. So that's one of the software products we're going to launch, and Karifi is going to be, if you want development environment on a cluster, tick a box and it will just go and deploy that. So that's what we're looking at potentially doing. So that's a very long intro, but that's the background.
Thank you. Welcome. Glad to have your interest in Karifi.
Yeah, memories came flooding back when I did CF push the other day, and it just worked in 20 seconds. I was like, God, I missed this.
Yep.
Docker files, not so much. Helm charts, nah. CF push, all day, every day, please. Yeah, hell of a lot simpler.
Yep, definitely. Okay, so anything else we have on the agenda for today? Doesn't look like it. Any last minute items? All right. Thank you all. I'll see you all soon.
Yep, very interesting call today. Thanks,
Thanks,
everyone.
everyone.